So now we need to talk about implied domains. An implied domain is what you get when the domain of a function is not explicitly stated or shown by a graph. So usually you have a formula for the function, and you're finding the domain from the formula without having been told what the domain is. So if the domain of a function is not given, we assume it is the set of all real numbers that give outputs that are real numbers. So you take the number, if you take a number in the domain and you plug it in to the formula, then the output of that you get from that has to be a real number. If it's not, then you couldn't use that input. So you'd have to take that input out of the domain. That's the basic idea. Okay, so we call these restrictions on arguments. That would be numbers that cannot be used for the argument. The argument is the stuff that you're doing something to. So like if you had a squaring function, if you're squaring x, then x is the argument. If you're squaring x minus 1, then x minus 1 is the argument of the squaring function. Okay, so the argument is sometimes x and it's sometimes not. So for us, at this point, there's really only two kinds of functions that we're going to look at. One is a polynomial. In a polynomial, there's no restrictions on a. What that means is that a polynomial, if its domain is not explicitly stated, then its domain is going to be all real numbers. So polynomials are pretty easy. You can plug any real number into a polynomial and you get a real number out. Just think about it for a while. Okay? Now, the second one we have is a function of the form b over a. And the rule here is that you can't divide by 0. It's a very simple rule that I'm pretty sure everyone knows. So the restriction on a, which is the denominator in this case, is that a can't be 0. That's not the same thing as saying x can't be 0. If y was, say, 1 over x minus 1, then x can't be 1. It's the x minus 1 that can't be 0. Okay? I'll show you an example of that in a minute so you can actually see it written down. So the restrictions for other types of functions will be covered or introduced as the other types of functions are introduced. So when we learn about logarithm functions, we'll learn about the restrictions on the domains of logarithm functions. Same thing with exponential functions, same thing with square roots and cube roots, things like that. But right now we're just doing these two types. Okay, the restrictions are on a. I already mentioned this. The restrictions are on a, the argument of the function. A is not necessarily the input x. So for example, so I actually wrote out one as promised. So y equals x minus 1 over x plus 2. The argument is x plus 2, right? It's actually the argument of the reciprocal function, 1 over something. So the argument here is x plus 2, and that can't be 0. It doesn't say x can't be 0, right? A can't be 0. So x plus 2 can't be 0, and then if you solve that by subtracting 2 from both sides there, you get x is not equal to negative 2. So that's your restriction. X is not equal to negative 2. And on the homework, they do ask you in places, what are the restrictions on x? And the restriction on x here, x is not equal to negative 2.